All right, 19.2, stretching, compressing, reflecting tangent graphs. So we've looked at the sine, cosine, and this is going to be day 1. Tomorrow we'll look at actually writing the equation. Today we're going to talk about graphing. Now, notice on this table that I have up here, we have some undefined values. That's because there are times where we are going to take 1, because remember, it's the sine divided by cosine. So when we looked at that unit circle, those y values, when they're 0 and are fine, but when the x values are 0, it creates an undefined issue. So if you look when pi over 2, the x value, that coordinate point, the x value is 0. And same thing at 3 pi over 2, and the x value is 0. So we can't divide by 0, we get undefined, which means we do have some asymptotes looking at the tangent function. So our first asymptote is at pi over 2, so we're going to go ahead and jot that down. And at 3 pi over 2, and we're going to get that one in. That means that our tangent graph is going to be fragmented because it's not going to touch different pieces of each other. And it kind of goes. This one starts 0, 0, we're here. And then at pi over 4, we're here. That's halfway between. And it's going to keep going. If we actually went to negative pi, we'd be at negative 1. So our graph does this bit. Then likewise, here at pi over 2, we have 3/4 pi, we're at negative 1, which is down here. Pi, we're at 0. And at 5 pi over 4, we're up at 1. So this graph is doing the same little snake bit. And this is all this is a series of. It keeps going. We have an asymptote here at 7 pi over 4, we're at negative 1. At pi over 2 here, and then over in this one, we'd be going up to positive 1. So it would repeat, and it keeps going in the same pattern. This is f of x is the tangent of x. This is your basic tangent function. Now, to be able to figure out what the shifts and translations, where those asymptotes and reference points are, we actually need to look at reference points. So the reference points are going to be defined by negative pi times b divided by 4 and negative a, and pi times b divided by 4, comma a. Those are the two reference points we'll use. The asymptotes will be at x equals negative b times pi divided by 2 and positive b times pi divided by 2. Generic function f of x equals a times tangent of 1 over bx. A still stretches the graph vertically. It's still our amplitude. 1 over b stretches the graph horizontally. So we're going to plot one point, or one, not point, I think that's a misprint. We're going to plot one cycle, not point, cycle of the transformed tangent function. Okay, so important things here. We need to look at our reference points. So we need to know that a in this case is 1/2, and that b, well remember this is 1/3 times x, and that's 1 over b, so that means that b is really 3. And we're going to use this to find our reference points. So our reference point says negative pi times b. Well, that's negative, b is 3, so my reference points become, that becomes negative 3 pi over 4, comma, negative a, so negative 1/2. My other reference point is just the positive of that, because remember, these are very much in patterns. The next thing we need is we need to get our asymptotes in there. So the asymptote is negative b times pi divided by 2. So that's negative 3 pi divided by 2, and then the positive of that, 3 pi divided by 2. Okay, so 3/2 pi and negative 3/2 pi. So we need to actually change our graph a little bit because we need to go all the way to the negative side. And we're only going to graph one pattern of this. So I'm going to kind of rewrite and move my tangent function. So I need to go, that would be 0, there's, let's see, 1, there's pi over 2, that's pi, that's 3 pi over 2, and there's 2 pi. So this would be 0, That'd be negative pi over 2, negative pi, negative 3 pi over 2. And I'm going to draw in my y right through the 0. And it's 1/2. So this is 1/2 and negative 1/2. I wrote it out a little further so it would space my graph out. And we're going to graph. Put in your asymptotes first. So I know here there's an asymptote. And at positive 3 pi over 2, there's an asymptote. I know that my reference points at negative 3/4 pi. Okay, I want you to think about that. That's going to be here, halfway between. I'm at negative 1/2. And at 3/4 pi, which is going to be almost between half a pi and pi, so here, and we're going to be at positive 1/2. And I know it's going to go through that 0, 0, so here we go. And it makes that little snake graph, and that's it. That's all you're doing. You're going to use your reference points just like you've always done. Identify A and B, and we'll be good to go. So let's look at one more example. One more example. G of x equals negative 2 times tangent of 2x. So again, we need to identify what A is, and that's pretty simple. A in this case is negative 2. Now, B is 1/2 in this case, because remember, it's going to be the opposite. So if it's written as a whole number, it means it's a fraction, and if it's a fraction in there, it's really a whole number. So it's just like with that H value all year long, and the B value. So we need to find reference points. So in this case, my reference points are, remember, negative B pi divided by 2. So negative 1/2 pi divided by 2. And when you simplify that down, that negative B pi divided by 2 actually ends up, negative B pi divided by 4. That actually ends up being negative pi over 8, comma, negative A. Well, A is negative 2, so if I do negative A, that would be a positive 2. So there's one reference point. This, to clarify, that's negative 1/2 divided by 4. Remember, we don't divide, we multiply by the reciprocal, and that's how I got the pi over 8. So the other reference point is just the positive of it, and the opposite of that, so that would be a negative 2. There's my two reference points. My asymptotes are negative B pi divided by 2. So negative 1/2 pi divided by 2. And again, we don't divide fractions. That's negative 1/2 times 1/2 times pi. That's negative pi over 4. So my reference points, my asymptotes are at negative pi over 4 and positive pi over 4. So I have to go over and adjust my graph here. And I need to go out. There's negative, move that a little too far. Negative pi, there's pi over 2. Because negative pi over 4 is going to be halfway between 0 and pi over 2. So let's get in our asymptotes. This is negative, by the way. So there's one here. And then there's one here. Our graph is being squished together. So we have a point at pi over 8. Negative pi over 8 is at positive 2. And positive pi over 8 is at negative 2. So the graph is going to go through that 0, 0. And there we go. We're good to go. We've done our job. Use your reference points. Use the equation for the asymptotes. It's all about identifying A and B, and don't let B fool you.